In this video, we are going to discuss batteries and fuel cells. Please read the detail in the OER textbook, chapter section 18.4. In the previous chapter section, we discussed the galvanic cells or voltaic cell that rely on the spontaneous redox reaction. This spontaneous redox reaction produces the electrical potential that can be used as electrical power supplies, as batteries and fuel cells. First, we are going to focus on the battery. Again, a battery is a portable voltaic cell that rely on a spontaneous redox reaction. We learned in the previous chapter section that when you have zinc that undergo oxidation and copper 2+ that undergo reduction, these together would produce a spontaneous redox reaction. And a battery that rely on this spontaneous redox reaction, the early battery is called Daniell cell, and also known as Crow's-Foot battery. The reason why the name is Crow's-Foot battery is because the two electrode, copper electrode and zinc electrode, the shape of these two electrodes look like crow's foot. Therefore, this Daniell cell also known as Crow's-Foot battery. This is an example of the galvanic wet cell battery. The reason why it's wet also because the electrodes are submerged into the electrolyte solution. This early battery produced low energy potential. Therefore, the early use of this battery is in telegraph stations. And as you can see, the battery that we are using now has been developed significantly from this early stage of the battery. And think about that, if you need to charge your iPhone, right, and if you have to carry this around, it's just not very convenient. It's also prone to leakage and also spill as well. Therefore, since then, since 1836, many more of battery has been developed, and we are going to take a look at this on the next page. Lead-acid storage battery is a modern type of wet-celled battery that is rechargeable. The rechargeable battery is also called the secondary cell. Here is the diagram that displays the discharging process of the lead-acid storage battery. Please note that you will need to correct this. The anode side of the discharge process would be lead solid, and the cathode side of the discharging process would be the lead oxide. The overall redox reaction of this process in the lead-acid storage battery is going to come from the reaction between lead electrode react with the lead oxide electrode in the sulfuric acid, strong acid electrolyte solution. And the process of this is spontaneous reaction that would produce lead sulfate and water. And if you determine the oxidation number of lead, you will see that this is the oxidation number of 0. Lead in lead oxide would have the oxidation number of +4. And the oxidation number of lead in lead sulfate would be +2. Therefore, you will see that from lead 0 to lead 2+, this would undergo oxidation. Therefore, it would be the anode. And lead oxide that have +4 of the oxidation number of the lead go to lead 2+ in lead sulfate. You will see that this reaction is the reduction half reaction. And therefore, this half reaction would be cathode. The spontaneous redox reaction that undergo in a forward direction spontaneously would produce electrical voltage, and eventually is going to produce lead sulfate and also water as well. And therefore, eventually, once the reactant is consumed and is produced the product of lead sulfate, if it's accumulated too much in the battery, it would cause the battery to go dead. To make the battery work again, we will need to get rid of this lead sulfate, which is the product. In order to do this, the alternator in the car would convert this lead sulfate back to the reactant. The reason for that is because, as we already know, that the forward direction is spontaneous, but the reverse direction would be non-spontaneous. Therefore, the alternator would supply the electrical current in order to causing this non-spontaneous process to undergo in the reverse direction in order to produce the two reactant in order to supply into the spontaneous redox reaction in the forward direction again. But one major problem of the charging of the battery is that Once the alternator supply the electrical energy into the reaction in the battery, the reverse process would occur, and also there will be another side reaction as well, which is the reaction from water. When electrical supply into the water would dissociate into oxygen and hydrogen, and during the charging process it will produce this side reaction that forming the hydrogen gas, which is very highly flammable. This highly flammable hydrogen gas would increase the risk of explosion. This would be one of the disadvantages of the lead acid battery. Another disadvantages of the lead acid batteries are they are very heavy and bulky. They're prone to leakage and spillage. They are danger of overheating during charging, and they are not environmental friendly because they contain lead and strong acid, sulfuric acid, and it also have risk of explosion as well. However, the lead acid storage battery is still used in most automobiles because it's rechargeable and also portable. It have low cost, low maintenance, and is very reliable as well. The next type of battery that we are going to focus our attention on is the dry cell battery. The name implies that this type of battery has no solution contained. The battery is dry, therefore it's going to be less prone to leakage. Okay, let's take a look at the first example, alkali battery. The name of alkali battery implies that the electrolyte that is used in this battery is going to be an alkali or a basic. Right, so it's going to be in the basic electrolyte, which if you're looking at the component here, the potassium hydroxide paste would be used as an electrolyte in this alkali battery. Therefore, when you will see that when the battery expired, you will see that sometimes you see the white stuff coming out, right, like white crystal that come out or leak outside of the alkali battery, and that's the identity of the potassium hydroxide. Okay. So for alkali battery, the anode for this would be the zinc, and the cathode would be the graphite lot that is inside the alkali battery. The advantage of this alkali battery is low cost, reliable, and also has various size as well, and it contains non-toxic metal. But the disadvantage is prone to leaking potassium hydroxide, as I mentioned earlier, and also they are not rechargeable. The battery that are not rechargeable, we call them the primary cells. Nickel cadmium battery is another common type of the dry cell that contain the cadmium as an anode and nickel oxide hydroxide as the cathode. The advantage of this type of nickel cadmium battery is that it's rechargeable, lightweight, and high power. But the disadvantages they are expensive, and also they contain the toxic metal cadmium as well. Another most common dry cell battery is the lithium-ion battery. The lithium-ion battery rely on the lithium cobalt oxide cathode and the lithium that embedded in the graphene sheet anode. In a spontaneous reaction or the discharging process, the lithium in the graphene sheet would lose an electron. The electron would travel from the graphene sheet to the other side of the electrode, which is the cathode that contain cobalt oxide. And the migration of the lithium ions, right, since the lithium is losing electron, is going to generate lithium ions, and that lithium ions would flow into the cathode side to embedded in the cobalt oxide to form lithium cobalt oxide. So therefore, the flow of electron would go from the anode to the cathode. And for the recharging process, it will be the opposite. For the recharging process, the lithium ions in the lithium cobalt oxide would accept electron, and it's going to migrate back to the graphene sheet until the recharging process complete, and then the discharging process can continue again. The advantage of these lithium ions is it is very high energy density, it have low shelf discharge and also low maintenance and also lightweight as well. But they are really expensive and they are sensitive to high temperature as well when charging and discharging. You can read more detail of these batteries in the OER textbook, chapter 18.4. Next, we are going to discuss fuel cell, which is also rely on the spontaneous redox reaction. Fuel cells are similar to batteries except that the fuel cell must have the constant input of the reactant. The reactant must be supplied constantly. The most common example of fuel cells is hydrogen fuel cell, or also known as hydrogen-oxygen fuel cell, which rely on the spontaneous redox reaction between the hydrogen and oxygen that spontaneously produce water and electrical potential. In this spontaneous process, if you determine the oxidation number of each of these elements, you will see that hydrogen would have oxidation number of 0, oxygen would be 0, oxygen would be -2, hydrogen would be +1 in water. Therefore, in this case, you will see that the hydrogen will undergo oxidation and oxygen will undergo reduction in this case. And the two half reactions are written right here under this diagram. And you will see that this balanced half reaction of the redox reaction, you will see that it's balanced in the basic solution because you will see the OH minus as the identity of the base. And for this reaction, you will see that the hydrogen is going to give off electron and oxygen would be the one that accepts electron. And for this fuel cell to work, the constant amount of hydrogen will need to input into the fuel cell, the same as for oxygen as well. So these two need to be constantly supplied into the fuel cell for the hydrogen to react with the oxygen gas, and the electron from the hydrogen would travel from the anode to the cathode for oxygen to accept, and eventually these two, the hydrogen as it loses electron, will become proton, and water once it accepts electron and also break apart and react with water is going to become hydroxide, and these two eventually would react together to form water. So the byproduct of the hydrogen fuel cell is very environmental friendly because it's only produce water. So it's an ideal of the energy resource that would not cause any environmental pollution. So that would be one of the advantage of the hydrogen fuel cell, which is the pollution-free emission and also have high efficiency as well, and it does not degrade over time. It can be installed quickly as well. The problem for this type of fuel cell is that if you think about it, the input of the oxygen, that would not have any problem because our atmospheric gas contains 21% of oxygen. Therefore, you can get the supply of oxygen just from the air. But the supply amount of hydrogen is the problematic. The hydrogen gas is not readily available in air. The hydrogen gas can be obtained from the reforming natural gas that can cause pollution, or it can come from the electrolysis of water, which also consume energy. And also the storage of hydrogen gas is difficult as well. Think about this. If you have your car run with the hydrogen fuel cell and you have to have a storage of hydrogen gas tank in your car, which is highly flammable, that is not very convenient and is very dangerous as well to have that carry around everywhere you drive to, right? The storage of hydrogen is an ongoing research. And hopefully in the future, we would have a better storage of hydrogen that is generate hydrogen in situ, that we don't have to carry the hydrogen storage gas everywhere we drive to. And that would make the hydrogen fuel cell car to be safer than it is currently. And here are an example of the fuel cell vehicle. And here are an example of the lithium-ion battery vehicle. You're probably familiar with this already as it's used in Tesla and other electric cars. Again, for the detail of this chapter section, please read chapter section in the OER textbook 18.4. Thank you for watching.